What's up viewers? So, during the previous video, tinalakay natin yung analysis of singly reinforced beam wherein nag-yield yung tensile reinforcement or yung bakal. In this video, tatalakayin naman natin yung analysis of singly reinforced beam wherein hindi mag-yield yung bakal. So, ano kaya yung pinagkaiba nila? So, gagamitin natin dito yung mga basic formulas natin sa RCD plus yung mga provisions ng NSCP 2015. So, again, samahan nyo ako hanggang sa matapos ang video ito. So, ito yung given na problem natin. So, a rectangular beam has a width of 280 mm and an effective depth of 500 mm. It has a reinforcement area of 4,072 square millimeters at the bottom. Balance steel ratio is 0.026. F prime C is, or FC prime is 25 MPa, while Fy is 414 MPa. So, question number 1, determine the depth of compression block. So, itong A. Number 2, determine the tensile force carried by the steel bars. So, yung value ng tension T. And number 3, determine the resisting moment capacity of the beam. Check for the moment capacity reduction factor. So, when we say resisting moment capacity of the beam, yan yung MU. Okay. So, paano natin malaman kung compression controlled or hindi nag-yield yung steel? Okay, so tignan ulit natin yung table sa NSCP. Okay, so compression controlled. So kapag yung actual strain niya is less than dun sa strain under, dun sa minimum strain under compression or maximum compression strain. And another thing is, so ito hindi ko nabanggit sa previous video, kapag yung makuha natin na actual steel ratio, so raw, so yan yung steel ratio. Kapag yung raw is greater than the maximum steel ratio, which is equal to 75% of the balance steel ratio. So, kapag mas malaki siya sa maximum steel ratio, compression controlled, steel does not yield. Meaning to say, hindi totally na-utilize yung Fy. So, hindi pa na-utilize yung buong Fy, nag-fail na yung beam. Kaya compression controlled. So, ibig sabihin nito, mas malaki sa maximum steel ratio. Ibig sabihin nito, over-reinforced. So, madami yung bakal mo or malaki. Kapag naman yung steel mag-yield, so ito yung hindi ko nabanggit sa previous video, yung raw, in between lang siya ng raw maximum and raw minimum. So, meron tayong minimum na steel ratio. meron din tayong maximum. So, ang minimum steel ratio based sa NSCP 2015 is ito. Yan. So, AS minimum shall be, so ito siya sa 409.6.1.2. AS minimum shall be greater of A and B, except as provided in section 409.6.1.3. For a statically terminate beam with flange tension, the value of BW shall be lesser of BF and 2BW. So, ito yung minimum area ng tension reinforcement natin. So, square root of F prime C over 4Fy or 1.4 over Fy BD. So, if AS provided at every section is at least 1/3 greater than AS required by analysis, so ito, the sections 409.6.1 and 409.6.2 need not be satisfied. So, yan na. So, ito yung ibig sabihin ng minimum steel ratio. So, now, ito yung tension controlled steel yields. So, AS natin is 4,072 square millimeters. We have beam width of 280 mm, 500 mm yung effective depth. So, this is the depth of compression block. So, ito yung neutral axis. This is the depth of the compression block, yung A. Ito yung neutral axis. Ito yung distance, yung C distance from the topmost of beam to the neutral axis. Ito naman yung D minus C. Tapos yung moment arm natin is D minus A over 2. So, paano natin masasolve to? So, we have given AS effective depth and the width. So, ito yung B natin. Ito yung D. So, yung rho natin is given by the formula AS over BD. So, that is equal to 4,072 over 280 times 500. And that is 4,072 over 280 times 500. That is equal to 0.029. While yung rho maximum, so compare natin siya kung greater than or less than sa rho maximum. So makuha natin yung rho maximum kapag minultiply natin yung rho balance sa 0.75. So rho balance muna, balance steel ratio is equal to ito 0.026. So therefore, the maximum steel ratio is equal to 75% ng 0.026. So dito pa lang makikita mo na mababa, na mas mababa yung maximum steel ratio. So 0.026 times 0.75 is 0.0195. So this is greater than rho maximum na 0.0195. Therefore, so steel does not yield or over-reinforced or compression controlled yung situation natin. Now, so since steel does not yield, so Fy is not equal to Fs. So, hindi niya na ma-reach yung point ng Fy bago siya mag-fail. So, kailangan natin ma-solve yung Fs. So, now, we have here, ito lagi naman 0.003. Tapos, ito yung strain natin ng steel. So, pa natin tawagin na strain sub S. So, by ratio and proportion, we have 0.003 is to C equals the tensile strain, the actual tensile strain is to D minus C. Okay, so kung maalala natin yung Hooke's law, sabi doon, yung stress is proportional to strain. So we have Fs is equal to strain times the modulus of elasticity. So yung ayun natin, pwede natin itong i-substitute dito sa formula kasi from here magiging yung strain ng steel will be equal to 0.003 multiplied by the quantity of D minus C over C. So Fs therefore is equal to 0.003 times D minus C over C multiplied by the modulus of elasticity of steel of 200,000 megapascal. So Fs, pag simplify natin, will be 600 times D minus C over C. Now, yung tension natin will not be equal to ASFY but ASFS. Kasi nga, hindi siya nag-yield. So, Fs lang yung mako-consume or yung may utilize na stress. So, now, equate natin. So, equal pa din yung C and T. So, we have 0.85 Fc prime AB is equal to ASFS. So, we have 0.85 Fc prime multiplied by, so ano yung Fc prime natin? So, we have Fc prime of 25 MPa multiplied by A multiplied by B of 280 equals AS. So, 4,072 times Fs. So, yung Fs natin, ito, times 600 times D minus C all over C. So, diba, yung natin, yung A is equal to beta 1C, wherein yung beta 1 natin is equal to 0.85. Bakit 0.85? Kasi yung Fc prime natin is less than 28 megapascal dahil 25 lang meron tayo. So, as per code, kapag yung FC prime mo is less than or equal sa 28 MPa, 0.85 yung beta 1 mo or yung beta factor. Now, substitute natin to dito. We have A is beta 1C. So, ito pa natin palitan ng 0.85 times C. Okay. So, pwede tayo mag-shift solve dito. Or actually, magka-cancel nga yung C natin. Yung C natin dito, magka-cancel lang siya kasi meron kang C dito. Meron ka din C dito. So, pwede makancel. Hindi siya magka-cancel pala kasi dapat pa rin nasa numerator. So, hindi siya magka-cancel, hindi. Magka-cancel siya if parehong numerator or parehong denominator. So, it cannot be. So, now. So, this will be a quadratic equation. So, kung isi-simplify natin ito, medyo mahaba-haba ito. So, i-shift solve na lang natin. So, this will be 0.85 times 25 times 0.85 times 280. So, C natin will be X equals 4,072 times 600 times the quantity of D minus C. So, ano ba yung D natin? Yung D is 500. So, times 500 minus yung C natin is X over C. So, shift solve natin. So, ilan ba yung value? So, mag-assume na tayo. So, assume tayo dito yung mga 150 para malapit. So, yung value na lumabas, yung C natin is 306.08 mm. So, masolve na natin yung compression block. Kasi, A is beta 1C. Therefore, A is equal to 0.85 times 306.08. So, A is equal to, so multiply lang natin yan. So, 0.85. So, we have 260.16 mm. So, yan yung depth ng compression block. So, ito na. 260.16 mm. So, ito yung A. Now, determine the tensile force carried by the steel bars. So, sa number 2, we have T is equal to ASFS. Yung Fs natin is ito. So, T equals AS times 600 times D minus C over C. So, we have T equals 4,072 times 600 times D is 500 minus C. Nakuha natin kanina is 306.08 over 306.08. So, yung T natin is 4,072 by 600 by 500 minus 306.08 over 306.08. So that is in Newton. So T is 1,547,913.434 Newton. So, i-divide natin sa 1,000. So, T is equal to 1547.91 or 913 kilonewton. So, that is the tensile force. So, meron na tayo 1547.913 kilonewton. So next, determine the resisting moment capacity of the beam. Check for the moment capacity reduction factor. So, yan yung tinatawag natin na strength reduction factor. So, ano ba yung ulit? So, balikan natin yung NSCP. So, ito. So, titignan natin yung actual na strain niya. So, compare natin. First, kung mas mababa ba siya dun sa ceiling strain ng compression controlled, or kung nasa transition ba siya in between or greater than or equal sa 0.005, which makes it tension controlled. So, titignan natin kung ano yung phi. Okay. So, now, for number 3, so kukunin natin. So, yung tensile strain is 2 D minus C equals 0.003 is to C. So we have tensile strain is to 0.003 multiplied by D minus C. So ang D natin is 500 minus, so yung C natin is 306.08 divided by 306.08. So yung tensile strain natin is 0.003 times 500 500 minus 306.08 over 306.08. So we have tensile strain of 0.0019. So ito din yung tensile strain na may subscript na S. So ito yan. Okay, so huwag kayong ma-confuse. Now, kunin natin yung maximum na strain para masabi na compression controlled. And that is equal to, so gagamitin natin dyan is Fy over ito. But since hindi siya nag-yield, so gamitin natin dito is Fs, not Fy. So that is equal to, ano ba yung Fs natin? Yung 600. So ang Fs natin will be 600 times 600 times the quantity of D minus C, 500 minus 306.08 over 306.08. So that is 380.14. So, mali pala ito. So, hindi dito kinumpare dapat. So, yung Fs natin, 380.14. So, erase natin to ha. So, less than siya sa 414 MPa. So, 380.14 divided by 200,000. So, that is equal to 380.14 over 200,000. So, that is so yung value nung strain natin, kung saan ito yung maximum na strain na napasok sa compression controlled or compression limit is 0.0019. So this is equal to the actual strain nung bakal natin doon sa situation. So, kapag equal, ano ba yung gagamitin natin na strength reduction factor, yung phi? So, ano ba ulit yung sabi dito sa table 421.2.2? So, kapag yung actual strain mo is less than or equal sa strain, so dun sa maximum strain na pasok sa compression control, ang gagamitin mo is kung spiral 0.75, others 0.65. Pasok tayo sa others, therefore 0.65 yung strength reduction factor. So itong gagamitin natin. So use phi equals 0.65. So now we can solve for the resisting moment capacity. So, yung MU. MU is equal to phi times AS Fs times the moment arm of D minus A over 2. So, yan. ASFS times the moment arm of D times of D minus A over 2. So, yan. So, di ba yung ASFS kanina, yun yung tension. So, therefore, MU is equal to phi times T times D minus A over 2. So, yung phi natin is 0.65. Yung tension is ito, 1547.913 kilonewton times D. So, yung D natin is 500 minus A over 2. So, yung A natin, 260.16 over 2. So, i-divide din na natin siya sa 1,000 squared. Or sa 1,000 lang kasi kilonewton. Tapos ito, mm. So, para maging Newton meter. So, we have mu is 0.65 times 1547.913 times the quantity of D minus A over 2 times 1 over 1,000. So, the ultimate moment natin, or the resisting moment, is equal to 372.19 kilonewton meter. Okay, so we already have our mu. So, nasagutan na natin to. And that concludes the lecture for analysis of singly reinforced beam wherein hindi nag-yield yung steel. Thanks for watching, guys.